Good morning. It's great to see the buzz in the room here. We have a great crowd today. I'm John Bitson, the Menard Family Director of the Sheila and Robert Challey Institute for Global Innovation and Growth. And welcome to the Human Progress and Flourishing Workshop. Really excited today for several reasons. First of all, first speaker of the year. So I'm excited to see so many people here. I'm also excited about the topic. This is a Human Progress and Flourishing Workshop. And an important reason for this is to make people aware of human progress and understand its foundations. And we have one of the top people in understanding that in the entire world. So one of the important inspirations for this entire series is Marian Tupy. So I'm really excited that he's here today with us. And then finally, I'm excited that there are plenty of hors d'oeuvres out in the back after the presentation. So please stick around. Marian said he'll answer questions until his flight leaves at 5 o'clock this afternoon. But anyway, he said he'll answer as many questions as you want. So super excited. Without any further delay, I'll give a brief introduction. Marian L. Tupy is the founder and editor of humanprogress.org and a senior fellow at the Cato Institute's Center for Global Liberty and Prosperity. He is co-author of the Superabundance Index, Superabundance, the story of population growth, innovation, and human flourishing on an infinitely bountiful planet, and 10 global trends every smart person should know, and many others you will find interesting. He has a whole bunch. He's appeared in a wide variety of media outlets. He's humble and doesn't want me to read them all, but just think of a media outlet, and he has participated in either an interview or written something for them. Tupy has received his BA in International Relations and Classics from the University of Witwatersrand in Johannesburg, South Africa, and his PhD in International Relations from the University of St. Andrews in the United Kingdom. But he does not golf, he told me. So super excited that Marian is here today, and thanks to everyone for being here, being part of this. I hope that we have this big a crowd in the future as well, and thanks to Marian for being here. So we're already late, so let's get going.
Thank you very much. Thank you. Thank you so much, John, for the kind invitation. Thanks to the Challey family for giving all the support to NDSU, and of course, thanks to all of you for coming. It's delighted to be in North Dakota for the first time. So my talk today is going to be about resources, and specifically about human ability to expand, I repeat, to expand our resource base into infinity. Infinity plays a role here that we'll get to in a second, but just keep that in mind. Now, the basic premise of my talk is that the more people we have, the more ideas we have. The more ideas we have, the more inventions and innovations we have. The more innovations and inventions we have, the higher the productivity gains, and the higher the productivity gains, the higher the standards of living. And indeed, our standards of living, in spite of what both parties occasionally might want to imply, are better than those of queens and kings of yesteryear. The connection between population growth, new ideas, new inventions, and prosperity is a well-trodden territory. I'm not proposing here anything Nobel Prize winning. Indeed, it is Nobel Prize winners such as Paul Romer, Robert Lucas, and Michael Kramer who originated these ideas. Unfortunately, the beneficial relationship between the number of people and human well-being is not universally accepted.
The great under-discussed factor in the climate crisis is there are just too many of us, and we use too much shit. Climate deniers like to say, there's no population problem, just look out the window of an airplane, something but empty space down there. But it's not about space, it's about resources. Humans are already using 1.7 times the resources the planet can support. In 1900, there were less than 2 billion people on Earth. Now it's approaching 8. We can't just keep going on like this. The world is just too crowded.
There are not enough people. I can't emphasize this enough. There are not enough people. And I think one of the biggest risks to civilization is the low birth rate and the rapidly declining birth rate. It is, and yet so many people, including smart people, think that there are too many people in the world and think that the population is growing out of control. it's completely the opposite.
There's scientific consensus that the lives of children are going to be very difficult, and it does lead, I think, young people to have a legitimate question. You know, is it okay to still have children?
People have been wondering about the relationship between population growth and resource abundance for a very long time. In 1798, an English scholar and preacher named Thomas Malthus claimed to have shown mathematically that population grows at an exponential rate. Population is the red one. It grows at an exponential rate, which is 1, 2, 4, 16, 32, whereas resources grow only at a linear rate, 1, 2, 3, 4. That's the green line over here. And the difference between them, the gap between them, he believed, must necessarily lead to starvation. The debate over the relationship between population growth and resources reached a fever pitch in the second half of the 20th century, when populations, especially those in what used to be called the third world, today we would refer to them as developing world, exploded, primarily thanks to the spread of scientific knowledge and better medical care. In 1968, a Stanford University biologist, Paul Ehrlich, he's still alive, just turned 94, picked up the baton of overpopulation from Malthus in his best-selling book, The Population Bomb. The Population Bomb starts with the immortal words, "The battle to feed all of humanity is over." In the 1970s, hundreds of millions of people will starve to death in spite of any crash programs embarked upon now. Now, Ehrlich scared and scarred generations of Americans with his ideas, some of his ideas being turned into feature films, such as the 1973 offering Soylent Green. In that movie, we have so little food and so many people that every time a human being dies, he or she is turned into a biscuit called Soylent Green, which is then fed to the people who are still left behind. This is the original poster, and I want you to note the date in the top left-hand corner. It is left-hand corner, yes. So this is what Americans in the 1970s, thanks in part to people like Paul Ehrlich, thought America would look like by 2022 when our book Superabundance came out. Here's a clip from the movie.
What is the secret of Soylent Green?
They're making our food out of people. Next thing, they'll be breeding us like cattle for food. You gotta tell them. You gotta tell them.
Promise, Tiger, I promise. I'll tell the exchange.
You tell everybody. Listen to me, Hatcher. You gotta tell them. Soylent Green is people! We gotta stop them somehow!
Watching movies from the 70s is a bad idea, but anybody recognizes the actor? Yes, indeed. Great American. I don't know about the acting, but that's a personal taste. Well, it's 2025, and we are still not eating each other. Instead of starvation, we've got an abundance of choices. I picked this picture because it reminds me when I go to Whole Foods and I'm choosing olive oil, I have to choose between the Portuguese, the Greek, the Spanish, the Californian, between extra virgin, virgin light, and something called stone pressed or cold pressed. I don't even know what it is, but my point is that there is a lot of choice out there. In fact, food supply is now so high around the world that famines have disappeared from the world outside of war zones. In 17th century France, there were 8 famines, which resulted in millions of deaths. Today, we have famines only in places where there is war, but in most cases, basically the international community steps in, provides food, but most countries are simply rich enough not to experience famines altogether. Now, so my point is that we have an abundance of choices. Now, in Superabundance, the book that I referenced, we try to estimate. We attempt to quantify growing abundance of commodities by looking at their prices. A rising price of a commodity, obviously, implies growing scarcity, while falling price of a commodity implies growing abundance. And prices reflect the behavior and expectations of 8 billion people across the world. You can think about the price mechanism or the free market as a giant calculator, providing just-in-time best possible estimate regarding of what is valuable, and more of it should be produced, and that which is falling in value, in which case you should produce less of that. The market tells us that we should have more iPhones because everybody wants them, and less or fewer rotary phones because only quirky people want those. But which prices are we going to use? We are all familiar with the nominal or current price. That's the one that you see when you go to a shop. Every time you pick up a loaf of bread or put a gallon of gas in your car, that's a nominal price. Now, we all know that we cannot work with nominal or current prices over long periods of time because of inflation. So we have to adjust nominal prices by inflation and turn them into what we call real or inflation-adjusted prices. Now, unfortunately, both nominal prices and real prices, by the way, that's a loaf of bread from 1922 Germany when it cost 1,000 billion Deutschmarks or Reichsmarks. That's what inflation does. It increases prices sometimes in a hyperinflationary way. But now there's a problem with both nominal and real prices. And the problem is that they don't consider what is happening in your pocket. So you very often hear older people say things like, oh, well, I was a young man, you know, a gallon of gas cost a nickel or a dime or whatever else. That may well be true, your memory is not failing you, but how much were you making at the time, right? Maybe you were making $2 an hour, whereas today you are making much more. And so, therefore, what we use in the book and in our research is so-called time prices. Time price is calculated by dividing the nominal price of a good, like a loaf of bread, by nominal hourly wage at the time of the purchase. So whereas nominal prices are measured in dollars and cents, time prices are measured in hours and minutes. Time price tells you how long you have to work in order to buy something. If today a pound of beef costs $25, and you are making $25 an hour, that means that a pound of beef costs you an hour of work. And in 10 years' time, or 20 years' time, a pound of beef costs $25, but you're making $50 an hour, that means that you're now working only half an hour in order to afford the same commodity. So you're twice as well off. Now, why did we choose to do that? Why did we decide to measure our research in time prices? Well, first of all, because time prices measure productivity gains both in prices and also in wages. Think about something like agricultural production, of which you know a lot in this part of the United States. Let's say that due to better agricultural techniques, you are now producing much more wheat per acre of land. And so the price of wheat is coming down. Yes, but at the same time, your typical worker who is bringing that wheat in is not using, I don't know, sickles and scythes. He is now using a powerful machinery, and consequently he's much more productive. So he's much better remunerated. He's bringing in much more money. So the price of a commodity can decrease, and the wages of the worker increase, and time price gives us a picture of the productivity gain that other prices don't. Second reason is that we don't have to rely on the estimates of inflation. Politicians often say, you know, inflation is overestimated. Sometimes it is, sometimes it isn't. We don't care about inflation. We don't care whether inflation is 2% or 5 million %, because we are always comparing nominal prices, the price at the pump at the moment that you put in your car, with nominal wages at the time of the purchase. So what happens in between doesn't really matter. Now, the third reason is that time prices allow us to do long-run research. If you just want to work with currencies, you can't really do that because some of the currencies are discontinued. Whereas an hour of work is the same in the United States in 2025 as it was in 1925. It is the same in the United States today as in China and whatever else. It's just an hour of work, so it works. And the last reason why we use time prices is because time is an independent variable. You cannot inflate it. You cannot, you know, it's out there. It is immovable due to human perception, and it is constant for general purposes outside of Einstein's theory of relativity, and it's equal for everyone. Everybody has only 24 hours in a day. So it matters what you do with those 24 hours a day. If instead of working 8 hours a day in order to be able to buy a meal, like somebody in India or Bolivia may do, you only work 8 minutes in order to buy food, you have all that extra time with which you can do other things. Maybe you can buy, you know, a baseball bat or a bicycle, or maybe you don't do anything at all but spend that time on sports or with your family. So that is why we use time prices. I'm now going to give you an example of how you generate time prices, because I really think it's quite important. So these are actual numbers. A loaf of bread in 1980 cost 50 cents. By 2025, a loaf of bread costs $1.93. Which means that bread got 286% more expensive in nominal terms. Very often when you open an American newspaper, they will tell you, oh, the price of this, that, and the other has never been higher. That's because our journalists are not that smart, and they don't realize that what they have to do, they have to adjust for inflation. So 50 cents in 1980 is equivalent to $2.04 in 2025, and we know that bread only cost $1.93, and therefore we can say that bread got 5% cheaper. Are you with me so far? Okay, one last step, time prices. Once again, we know that bread cost 50 cents, but hourly wage in 1980 was $6.57 for a blue-collar worker, let's say somebody making a car in Detroit. And that means that our blue-collar worker had to work 4.57 minutes in order to buy a loaf of bread. By 2025, bread increased to $1.93, you can see it here, but hourly wages of blue-collar workers have risen to $30.84. Yes, 84 cents, which means that you now have to work only 3.76 minutes, and therefore that means that bread got, oh, sorry about that. The buzzer is quite sensitive. It got 18% cheaper. So you have a difference between thinking that bread is 300% more expensive in nominal terms, but in time prices, it's actually 18% less expensive. Another thing which people don't appreciate is that prices can increase ad infinitum. They can increase by 300%, they can increase by 3 million%, but prices can only drop by 100%. Once you get to minus 100, it means that something has become completely free. Okay, so here is one such long-term study I did last year. Don't panic, we are not going to go over all of them, but we will do one, and that is a difference in the price of eggs between 1919 and 2024. Why 1919? Because that's the earliest time that I could find federal government records as to what were the nominal prices of eggs back in 1919. So the nominal price of eggs, and why am I talking about eggs? Because eggs became a very important aspect in the last election, right? People were saying eggs have never been that expensive. So a dozen eggs in 1919 cost 61 cents in nominal dollars. By 2024, that increased to $1.96. And so in nominal terms, prices were 220% higher. A blue-collar worker had to work, oh, come on. So a blue-collar worker in 1919 had to work 1.4 hours in order to buy a dozen eggs. By 2024, he or she had to work 0.05 hours in order to buy a dozen eggs. So, do I need to point in a certain direction or something? Okay. So, in time prices, the price of eggs fell by 96%. And I told you the lowest it can go is 100%. That means that for the same effort that bought you 1 dozen eggs in 1919, you can now get almost 27 dozen eggs in 2024. So abundance of eggs has risen by 2,500%, and it doubles in 21 years, which is another way of saying is that if on the current trends, the same amount of time that bought you 1 dozen eggs in 1919 will get you 52 dozen eggs in 21 years' time, okay? So there are obviously many more such studies that I have produced over time. So in the book, we looked at many different commodities. This is just one of them. I wanted to include this particular study because during globalization, what we have observed is obviously billions of additional people joining the global economy. The global economy was growing, and so you would expect that as the global economy grows and we are using many more resources, resource prices should go up. In fact, as we have found, resource prices of 50 most used commodities in the world, you're only seeing some of them because if I put all 50 there, you wouldn't be able to see them, but the time price of the 50 commodities that we looked at actually fell by 72%, which means that instead of 1 unit in that basket of 50 commodities, you can now get 3.5. Pork was the best performer. It fell by 85%. So instead of 1 pound of pork, 36 years later, or 38 years later, you are able to get 6.5. And we are seeing this throughout our work. Now, in our work, in the book, we have looked at 18 different data sets, not 18 commodities, but 18 different data sets, including hundreds of different foods and fuels and minerals and metals, even some services. And we never found any of those, in any of those data sets, that abundance was decreasing. So on this chart, I'm going to show you, this is a percentage change in population, how much population grows. That's on the horizontal line. And on the vertical line, you will see change in resource abundance, increase in resource abundance. So population increase, increase in abundance. Remember what Malthus said, the more people you have, the less abundant resources must become. But of course, you see nothing below 0 here. Why? Because we didn't find any resources becoming less abundant. They're all becoming more abundant. Now, resources can increase at 2 different speeds. One we could just call increasing abundance, the second one we call superabundance. What's the difference? If population and abundance increase at the same rate, then we would expect to see them along this 45-degree line. But in fact, when we concluded our research, what we found is that every single case, every single data set was increasing at a superabundant rate, which means that every additional human being, on average, contributes more to the growth of resources than they consume. We build more, on average, than we consume. So you will recall the Malthusian proposition. It's population which is increasing, and resources are increasing at a lower rate, therefore you must get starvation. But in reality, what we found was the opposite. It is resources which are increasing at a faster rate than population. Okay, so, and it is the gap between population growth and resources that is the outcome of the new ideas that are born in the human mind. So in our methodology, we always start with the overall population. Not everybody is an inventor or innovator. In fact, only a small fraction of humans actually invent or innovate anything. So the more people you have, the more likely it is that one of them will emerge who is like Elon Musk, or maybe somebody like Steve Jobs, who are really going to change the world for the better. maybe somebody like Patrick Bell, who in 1827 discovered a new way of bringing in the harvest. Then, over the next 100 years, what happens is that this particular machinery gets innovated all the time until you end up with something like a modern combine harvester, which means that we now have much more plentiful food at much lower prices, and as a consequence, we can live better. Now, the total number of people is not the only reason for increasing resources and for human progress. If total number of people was all that mattered, China would always have been the richest country in the world, because it's always been the most populous country in the world. It's only after the free market reforms that start after 1978 that when the innovative spirit of the Chinese people was unleashed, that China was able to go from poverty to riches. So superabundance really equals population times freedom. The next obvious question is, can superabundance continue into the future? Remember what I said, I was talking about an infinitely abundant planet. Well, not everybody thinks that. Kenneth Boulding, the American environmentalist, says anyone who believes in indefinite growth on a physically finite planet is either mad or an economist. I will try to persuade you that it's possible to have infinite prosperity. Why? Because I believe that the total number of atoms actually matters very little. What matters is the knowledge that goes into forming those atoms into valuable things. This is a Lamborghini Huracan worth $250,000. This is a Lamborghini Huracan worth $5,000. But the number of atoms, the number of resources that have gone into that car were exactly the same. It's just that the atoms were arranged intelligently in the first picture and chaotically in the second picture. And there are myriads of different ways in which we can increase our resources moving into the future. Now, one of the most important ones is obviously increase in supply. When prices of resources grow, what we do as humans, we go and search for new deposits of those resources. So, for example, when the price of oil goes up or gas, we'll look for new deposits. But there's another way of increasing supply, such as through technological breakthroughs such as fracking, right? Using the old drilling methods, we were able to get only so much oil out of the ground, and whatever else was there became uneconomical to drill for. But with fracking, we are now able to get at previously unreachable resources. Similar thing can be said about fertilizing. Again, this is an agricultural state. In the old days, we would have to use human or animal excrement in order to fertilize our fields. Later, we discovered guano, which is just basically bird droppings. But we used up all of those. Are we starving? No. 50% of humanity is dependent on artificial fertilizer, which is basically natural gas turned into ammonia, which is then sprayed on our fields. So this is how technology comes into the rescue of humanity. Another way in which we can increase our resources is through increased efficiency. That can be relative. A can of Coke used to weigh 3 ounces of aluminum or tin back in the 1950s when cans first came out. If you wanted to prove that you were a strong guy, you would actually crush a can of Coke or a beer with your hands because it was bloody hard. Today, a can of Coke weighs only half an ounce of aluminum, and even a child can squash it, right? So there is a relative efficiency gain. But of course, we produce many more Cokes. So what we need to look at is absolute efficiency gains. So Ido Wernick, who is a researcher at Rockefeller University, has looked at 100 economic resources in the United States. And for the longest time, what you saw was that the use of resources and American economic growth were going in parallel. Then about 15 or 20 years ago, what started happening is that American growth continued, but the absolute number, the absolute tonnage of resources started to go down. In other words, even though the American economy grows at roughly 2% a year, the absolute tonnage of things like copper, iron, and so forth is actually going down. So we are becoming super efficient, hyper efficient in terms of how we produce. We can also increase value from something as simple as, for example, a grain of sand. When sand was first melted down, people would use glass for beads in order to beautify themselves. Sometime later, people realized that they could use glass for cups. Sometimes later, they could use it for windows. Now, we are using glass in fiber optic cables, and we are using it in computer chips. So with every step of the way, we can increase the amount of value that we are getting from a particular resource. The same can be said for lithium. We used to use it in ceramics, now we use it in batteries. Graphite, we used to use it in pencils, but actually now we are using it in making aircraft, so value added. Another way in which you can increase your resources is to turn something which was useless and maybe even dangerous to something that is useful. If you go to a developing country or a very poor country, you will see a lot of gas fields or oil fields that are burning. What they are burning off? They are burning off gas because they don't know what to do with it. In the old days in the United States, people were drilling for oil. They didn't care about gas. When gas came out and you lit your cigarette, you killed yourself and everybody else on the rig. So what we did instead, we used to burn off that gas. Today, in advanced economies, we capture that gas and then we pipe it to homes where they can heat your home in winter time. So, in a way, you could say that everything, every resource is useless without new knowledge, new information. Coal was useless until the moment came when we realized that we could power the Industrial Revolution through steam. Okay? Uranium definitely was useless until we were able to use it in order to create fission reaction and electricity that way. Substitution, an incredibly important aspect of economics that is greatly underappreciated. We no longer kill whales for their oil in order to read by candlelight. No, what we do instead, we use fossil fuels in order to generate electricity. Guano, as I said, was bird droppings that we used up for agriculture. Now we use synthetic fertilizer, ammonia. We use synthetics instead of animal furs. And when people tell you things like, oh my goodness, there is only so much lithium in the world, how are we going to power all those electric vehicles in 20 or 100 years' time? Well, the answer is, who says that we'll need lithium in 20 years' time? You know, maybe we'll be using sodium-ion batteries, and sodium is one of the most plentiful resources on Earth. So substitution is very important. This is my enemy number one. Okay, dematerialization. This is in many cases for young people a replacement for all sorts of things. Cameras, radios, compasses, measurement devices, television. So instead of, imagine a pile of things full of atoms that you would need in prior generations that can be combined into this. That process of using ever fewer materials in order to accomplish your goal, that we call dematerialization. One of my favorite examples is, until really 15 years ago, if you walked into any hotel room in the United States, there would be a thick blue copper cable coming out of the wall that you would have to physically plug into your computer in order to get internet. All those cables are gone now, because we have completely dematerialized, 100% dematerialized access to the internet. We are not using anything physical. We are using the airwaves. We are using Wi-Fi, right? So this is how you can see how, because we don't care as human beings how we get from point A to B. We just want to get to point B. And if it doesn't require any expense, such as, for example, mining for copper and then turning it into cables, so much the better. We could make the same argument about books being replaced by tablets, email, replacing snail mail, streaming instead of vinyl, and so on and so forth. Reuse. During the Second World War, during the Manhattan Project, the only way that you could make magnets in order to enrich uranium was by using a lot of silver. So the American government lent the Manhattan Project 14,000 tons of silver in order to produce our first two atomic bombs. I say our because I'm an American now. But all of that was returned back when the Manhattan Project concluded, and better ways of getting enriched uranium were found. So there's a way in which we can, of course, reuse everything that we have. We have on this planet exactly what the Stone Age man had. Nothing has changed. We have shot up into the space few tons of titanium, but other than that, everything that as humans we ever had, we still do. If for some reason we use the knowledge of how to make steel, well, we can tear down some of our buildings and get steel that way. The point is, reuse is actually a very important part of how you can get more materials. Transmutation. Transmutation is, of course, a stuff of alchemy. That's what alchemy was devoted to. People used their entire lives searching for the Philosopher's Stone, a magical entity which would allow you to turn base metal, something like lead, for example, into gold. Transmutation is a reality. It's happening all the time. Americum, which is a resource to be found in fire alarms, for example, is a transmuted entity. And of course, we know how to turn lead into gold. We have done so 40 years ago through neutron bombardment. The only problem is that using our current methods and using the energy required to do that, every ounce of gold from lead would cost quadrillions of dollars. But turning lead into gold is not beyond it doesn't transgress any physical laws. We just need a free source of energy, maybe by building a Dyson sphere around the sun or something like that, which will then enable us to use that energy in order to transmute any metal into any other metal that we might possibly want. What about minerals? Well, we know how to make the most expensive mineral, diamond. What we do these days is we heat methane to very high temperatures, and then we deposit what now becomes carbon vapor, one layer on top of another, until we end up with a synthetic diamond, which is chemically and physically indistinguishable from natural diamond, which is why the prices of natural diamonds are dropping like a rock. A famous American economist, Joseph Schumpeter, once said that the beauty of capitalism is not that it produces silk stockings for Queen Elizabeth, but it brings silk stockings, for those of you who don't, surely some people must know what a silk stocking is. The beauty of capitalism is that it brings silk stockings into makes it affordable to an ordinary girl. That's what he said. Well, the beauty of capitalism also is that diamond rings are no longer seen really as a status symbol. They are no longer seen, or decreasingly seen, as something that is tremendously unaffordable. And if the prices of diamonds continue collapsing, well, every woman will be able to afford, or husband will be able to afford to buy a 5-carat diamond ring, and it won't be a big deal because, as I said, they are becoming very common indeed. Now, finally, of course, should something unforeseen happen, and we are really running out of something, there is always space mining. There are 3 distinct technologies which are coming together in order to make space mining possible. One of them is, of course, solar energy. The other one is AI, and the third is robotics. Between solar energy, AI, and robotics, it is perfectly within the scope of our imaginings that would be able to send armies of humanoid robots to the asteroid belt, for example, which is very rich in water, or to Mars in order to terra-colonize Mars. But we might need those things thousands of years into the future, by which time we will be a spacefaring civilization. So my point is that for practical purposes, our resources are in fact infinite. Paul Romer, the Nobel Prize-winning economist, makes an observation that is important. What we really need is not more atoms. We have plenty of those. What we need is new knowledge to turn atoms into something that is useful. And what Roma says is that we constantly fail to grasp how many ideas remain to be discovered. The difficulty is the same we have with compounding. Possibilities do not add up, they multiply. So this is the periodic table. It has roughly 100 elements in it, 100 stable elements in it. And if you were to combine two of those elements, which is to say tin and copper, you end up with the Bronze Age, right? But in order to combine two elements from the periodic table, you need to do up to 10,000 calculations because it's 99 times 100. And so few people do that. What we do instead, we rely on luck. Somebody just happened to combine tin and copper and came up with bronze, which then became Bronze Age, right? But if you were to do it in a laboratory, you would have to do 10,000 different calculations. Once you get to 4-element compounds, we are talking about 92 million different combinations that you have to do to come up with alloys, which are, for example, very useful for metro travel, such as this one in Washington, D.C. But once you start thinking about combining 10 different commodities or 10 different elements, there are more possibilities since the number of seconds, more possibilities than the number of seconds that have expired since the Big Bang 13.5 billion years ago. So it's obvious that far too little time and far too few human beings have appeared on Earth in order to but scratch the surface of the knowledge which is still available to us to be discovered in order to make the world a better place. I think that between human beings and AIs and quantum computing, which can run trillions of calculations and simulations in minutes or hours, we are on the precipice of the greatest discovery of knowledge in human history, and that human progress is going to take off even more than so far, and that our lives are going to be much richer moving forward than we have gotten used to. Thank you very much. Yeah, please, questions. Yes, ma'am.
Thank you for the beautiful presentation. I'm curious to know when you talk about superabundance.
About what?
Superabundance.
Yes.
Like, I was curious to know why the focus was just on food. And because we all know that the human existence is a combination of food, shelter, health, and family. And why the presentation was just focused on food, and how we would also like to see how it relates to other critical aspects of human life. Also, I'd like to ask that this superabundance, when we talk about it, who is it really benefiting, and at what cost is it benefiting people? So, recently, we've been hearing articles about how people are complaining about standard of living, and the distance between the average Americans and Billionaires keep increasing with time. So it feels to me that the superabundance is focused on one side and ignoring the realities of other people.
Get it. Okay. So the answer to your first question is no, we didn't just look at food. There were hundreds of different commodities that we looked at, including fuels, minerals, and metals. Now, why is that important? Is because the cheaper they become, the cheaper the inputs into the production process. So if you want a cheap output, you first need to have cheap inputs. And so by showing that everything is falling in time prices, everything is becoming much more affordable, you can see why, for example, a bicycle, which consists of rubber and metal, would be much cheaper today than it was 100 years ago, because, in fact, that's the reality. Same goes for electronics and so forth. You are quite right to say that there are certain aspects. Now, we weren't cherry picking. The reason why we also wanted to look at those commodities is because they remain the same over time. A ton of, I don't know, coal or a barrel of oil is the same as it was 150 or 170 years ago, right? So that allows us to actually provide a consistent look at how things, how much more affordable things have become. But there are, of course, some aspects which is much more difficult to measure. For example, the cost of housing, right? Houses today are much larger than what they were in the 1950s, for example. They are filled with 2 or 3 bathrooms, whereas in the old days, 1 bathroom, if you were lucky. They are much more insulated against elements. They are much better constructed and so forth. My point is that once you move beyond commodities and start talking about things like services, for example, things get much more complicated, and that's when you have to, as a scholar, start making a lot of calls that become dubious and possibly even attack to criticism. The reason why this book has never been criticized is precisely because we ignored average wages which are skewed by the people at the top. We only looked at American prosperity from the perspective of blue-collar wages and unskilled wages, so somebody like a janitor. So when I talked about the prices of eggs, I was talking about it from a blue-collar wage standpoint, not an average wage standpoint in the United States, because that would open us to criticism that we don't take inequality into account. Lastly, I would urge you to look at recent reevaluation of the look at the American inequality. It is true that American income inequality is slightly higher than what it was in the 1970s, but it is certainly much lower than it was 100 years ago. The paper I'm referring to is by can't remember. Last thing on inequality, and I think this is a very important message for everybody to take home. When American government talks about inequality, when our statisticians talk about inequality, they talk about a notional market income. The notional market wealth or income of somebody like Elon Musk is $400 billion. If he were to sell his stock tomorrow, the first thing that would happen to him is that it would drop to 200 billion because the government would take about 50% of it. Okay? For reasons that I don't quite understand, but I think it suits both parties, we continue to measure inequality by not accounting for taxes and transfers. So as far as the American government is concerned, what matters is the market income of people across the board, except that nobody ever sees their market income. If you are making $1 million on Wall Street, you never see that $1 million. It's a figment of imagination. The first thing the government does is take 36% in taxes, then there is that's the federal government, then the state tax, etc. Before you know it, you're under 500,000. And the people at the very bottom of the income ladder, they may not be making any money, but they're still bringing in roughly $70,000 per family in transfers. These are Medicare, Medicaid, pensions, schooling, food, housing allowances, etc. So we have to be very careful what measure of inequality we are looking at. If you have a comeback, please go ahead. Otherwise, we'll move on. And yes.
Thanks for your wonderful presentation. My question was, at what stage of your life you had the thought that population problem is not a problem, it's rather a boon for economy?
When did I start thinking that?
Yeah.
By becoming aware of one of the world's, if not the most famous wager in human history, between Paul Ehrlich and Julian Simon. I would highly recommend that you look it up. It's got its own Wikipedia page. But basically, Julian Simon, who was my predecessor as a senior fellow at the Cato Institute, unfortunately he died before I joined Cato, wagered Ehrlich to pick 5 metals that were supposed to become more expensive over time. Ehrlich did so, but in fact they become cheaper over time, even though the population of the world rose by 800 million over the decade between 1980 and 1990. So that was a first sort of empirical dismissal of the idea that there were too many people in the world. Now, I don't know where you're from, but of course in China and India, so you're not from India, but in India we did have terrible human rights abuses as the Indian government forcibly sterilized millions of people in order to prevent quote-unquote overpopulation. In China, we estimate that 400 million people were either killed or prevented from being born due to the Chinese one-child policy, which of course, in a typical communist fashion, shot the communists in the foot, because now the Chinese population is actually decreasing at a very rapid pace. It's now lower than India. I realize that you're from Bangladesh, it's not the same thing.
But we also have a large population.
Right, yeah. Yes?
We tend to have a waste stream whenever we transmute or make something new. We tend to have a waste stream. For example, if we all go to lunch at the cafeteria, we probably produce enough styrofoam to fill a garbage truck. So there's always this waste that we're also creating, along with creating new things. How does the waste stream, like climate warming, how does that factor into what we just discussed?
Well, first of all, I believe that capitalist economy is, by and large, a circular economy, which means that very often we will use something that we used to think was wasteful, and then we recycle it in something that is actually that actually helps our standards of living, and that happens all the time. When we first started drilling for oil, for example, we were only interested in certain part of the barrel of oil. I can't tell you now. Somebody else here will be able to tell me there is the bottom, there is the middle, there is the top. And only some of it was useful for cars back then. The rest of it would be discarded. But then we realized, oh my God, we can make kerosene, we can make plastics, we can make this and that and the other. So capitalist economy is a circular economy in a sense that a profit-making enterprise hates to waste anything. They're always on the lookout. Perfect example, fisheries in Norway. I mean, they are turning skins of fish, which they have filleted. They used it into cosmetic products and God knows what else. So you never want to throw something that can potentially. If you're worried about things like landfills and so forth, well, of course, the idea here is to try to get to a point where we can incinerate stuff that we don't need in a 100% environmentally friendly fashion. If you can make, for example, a closed circle energy delivery, whereby, for example, you can incinerate plastics and stuff that you don't need, but generate heat from it to maybe heat water to produce gas that will run turbines that will then create electricity. That sort of thing that people are working on. And once again, it's only a question of really perfecting systems that already exist. There are incineration factories in Singapore, for example, which are 100% environmentally friendly. They are not contributing anything to global warming or anything else. There was a question, yes?
Yeah, it was a good presentation. I very much like the way you showed just the way commodities and a lot of things we use got much cheaper. My question is, what do you think caused that? Maybe is it capital? You mentioned capitalism, innovation, trade. What factors primarily have led to that tremendous decrease in commodity prices?
I would say the same forces that are behind liberal democracy, rule of law, behind medical progress, innovations. Innovations are the key. The innovation is what drives everything forward. Now, Joel Mock here from Northwestern University likes to say that every innovation is a statement of rebellion. It is an act of rebellion against the status quo. It doesn't matter whether you're coming up with a new religion like Jesus Christ 2,000 years ago in the Middle East, or whether you are proposing that people shouldn't be sent to jail without habeas corpus, or whether you are proposing that germ theory of disease is better than believing in miasmatic theory of disease, which basically believes in bad air and whatever else. Every single one of these discoveries, innovations, which takes humanity forward, is an act of rebellion against the status quo, be it political or economic or religious or whatever else. And so that's the key. Now, the big question is, why didn't innovation succeed before? Why is it only in the last 250 years or so that innovations really took off, first in Western Europe and then in North America? Why were we able to innovate when in the past efflorescences of innovation, as Jack Goldstone calls it, moments when civilization rose and they fell, every single time before modernity, those innovations were strangled by the powers that were threatened by the innovations, right? So if you're a high priest in Egypt, you might not be very keen on a new religion, for example, emerging, or if you are a member of a guild in Genoa, you might not be terribly keen on somebody starting their own shop and whatever else. So the status quo, remember, innovation is a rebellion against the status quo. So the status quo power will always try to strangle the innovative forces. And usually in history that has happened. So I think that one of the most important aspects of economic history is to explain why in Europe this didn't happen 2.5 centuries ago, 2.5 to 3 centuries ago. Now, the argument that I personally am very attracted to is one made by Eric Jones and Steve Davis, which is that it was the interjurisdictional competition between European states. So what tends to happen, the worst case scenario is where you have an empire, the Chinese empire, crack down on innovation, the Russian empire, crack down on innovation, the Spanish empire tried, the Ottoman empire definitely did. Because in empires, big chunks of states, what the governing elite is primarily concerned about is domestic discord, not being taken over by foreign powers. So you're not really terribly concerned whether the Mongolians are going to invade you or the Vietnamese or whatever else. You are so powerful that you don't worry about being subsumed by foreign forces. What you are worried about is domestic discord. And so you want to stamp out every act of rebellion. Europe was different. Europe had empires overseas, but Western Europe was disjointed on the continent. And those powers were at war with one another all the time. The French were worried they were going to be taken over by the Spaniards and later by the British. The British were worried they were going to be taken over by the French. The Dutch were worried that they were going to be taken over by just about everybody else, right? And so the argument here is that the governing elites in European states worried much less about domestic disruption than they were worried about being conquered by their enemies abroad. And so they were much more willing to entertain acts of rebellion, innovations, in order to improve their fiscal and military status in order to be able to defend themselves from enemies from abroad. So it is that interjurisdictional competition, competition between states, that is so important. And if you will, this argument then takes you over to questions about, for example, the role of Brussels, that Brussels plays in dumping down European innovation, the role that a powerful national city like Washington, D.C. can limit innovation in the United States and so forth.
So I'm very much like the 250-year mark you mentioned there. That's also when globalization 1.0 started as well. So interproperty, transatlantic, trans-Pacific trade. So I would argue that's probably a part of this as well.
I'm not sure, because if, for example, this is the argument about Colombian exchange, is that Europeans get, for example, better food from Latin America, except that you have Colombian exchange between South America and Africa. So the same food that was exported to Europe was also exported to, the same food items also found their way into Africa and into Asia. But they didn't result in economic takeoff. So that would be an argument against your argument.
So unfortunately, we're out of time, but let's all give a round of applause again to Marian for outstanding. Thank you.